I'm sure you know that we can use a variety of units in measuring. For example, temperature can be measured in Celsius or Fahrenheit degrees. Length can be measured in imperial, inches, feet, and miles, or in metric, centimeters, meters, and kilometers, and so on. Angular measurement is no different. We can measure angles in degrees, that's the units we're familiar with, or we can measure an angle using radians. And that's what we're going to talk about today. I've assembled some tools for Nadia and Daryl to use, and what I'd like you two to do is to create a central angle that cuts off an arc length of 1 radius. And I'd like you to do it on 2 of these round objects here. Now, some of this rope you might find too thin, I don't know, maybe too thick, but I think you should have enough tools here to do the job.
Okay.
All right, so go to it.
Well, if we're going to make an angle, we'll need an initial arm for our angle.
Okay. And I guess I'll just tape that down there. Okay.
Okay, and since it has to cut off an arc length of 1 radius, we'll need to know how big the radius is.
Okay. Okay, I'll just cut that off for you.
Okay. So it should be measured to about down there.
Okay.
Okay, that's marked off correctly there.
Okay, and every angle, I guess, needs a terminal arm, so I'll stick that there. And just tape that down, too. Okay.
Very good. So this is your angle that cuts off an arc length of 1 radius, right?
Mm-hmm.
Okay. Try it again with this can of worms.
Okay. I suppose the problem here is that you don't know exactly where the center of the circle is.
That's right. It's not clearly marked. There's a bit of scuffing in the center, but you can't really be sure. So what can you do?
Well, I guess I know that any chord on a circle gets bigger as it goes towards the diameter, and it's going to get smaller as it goes away.
Okay.
So I'll just try and find where it's the biggest, and that looks to be right about there.
Yeah, I'll just mark off the center for you.
Okay. I'll just cut that diameter off. Okay. Okay. And if we want the radius, I'll just fold that in half. Cut it off right about there. Okay.
Initial arm again.
Okay, and then I'll just measure 1 arc length.
And there's your terminal arm.
Okay.
Super. Once again, you've created a central angle that cuts off an arc length of 1 radius. Are these 2 angles the same size?
Well, we can see.
Okay. See, do those line up? Boy, oh boy. If they don't exactly, it sure is close. Do you think they should be the same?
Well, I think they should be.
You know what? You're right, and that's because of what our definition is. What you've created is an angle of 1 radian. Now, an angle of 1 radian is defined as an angle that is subtended by an arc of measure r on a circle whose radius is length r. Or in general, the definition of an angle theta in radians is the ratio of the length of the arc which subtends the angle to the radius. Therefore, theta equals arc length over radius when theta is measured in radians. You understand?
Yeah.
What then would be an angle of 2 radians, Daryl?
Well, I suppose if your radius is always constant in any circle, then theta is going to equal the arc length. So if this is 1 arc length,
then that's 1 radian.
right, and if you want 2 radians, you just have to double the length of your arc. And if you put that in there, that should be just about 2 radians.
So this angle here is 2 radians.
Yeah.
Okay. What would you do? You don't have to do it, but just tell me, what would you do if you had to have an angle of 5 radians?
Well, if we've got 2 here, I would just measure out 3 more arc lengths, and then lay that across there, and that big long angle would be 5 radians.
Okay. Would there be another way to do it other than measuring it out with a string like that, Nadia?
There's probably a way to calculate it or something.
Sure. What if you measured the radius, found it was 7 centimeters, and you needed an arc length that would be 5 radians, or an angle of 5 radians? You'd take 7 centimeters, the radius, times 5, cut an arc length of 35 centimeters. You could do it that way as well. Okay? Now, do you two feel that you understand a little bit better now the idea of what a radian is?
Much better.
That's good. Thanks a lot for your help. Now here's some more information on an angle of 1 radian.
At first, it may be difficult to clearly understand an angle of 1 radian relative to an angle of some degree measure. So to help us, let's use the following demonstration. Consider a circle of radius r. If we take a segment equal in length to the radius and place it along the circumference, we can obtain a central angle of 1 radian. Consider also an equilateral triangle with sides equal in length to the circle's radius. Remember, an equilateral triangle is also equiangular. The three angles each measure 60 degrees. If we look at the circle and the triangle together, comparing the measure of the angle of 1 radian to one of the 60-degree angles in the equilateral triangle, the 60-degree angle cuts off an arc slightly more than 1 radius length. We see that the angle of 1 radian is just slightly smaller than an angle of 60 degrees. Actually, 1 radian is approximately equal to 57.3 degrees.